This video will walk you through the ambiguous case or solving SSA side-side angle oblique triangles. Remember that oblique triangle means that it may or may not have a 90-degree angle, and we pretty much won't be looking at 90-degree angles for SSA. So let's review the chart, and just so that you can reference this in your own paperwork, this is in your lesson 5.3 notes. And this chart is on that front page of the notes. And what you want to do is you remember that it's called SSA because you're given two sides and the angle that is not between the two sides. So you're given two sides and the non-included angle. And so the first thing that you want to do is look at the angle, and if it's less than 90, you want to look in this column. And if it is greater than 90 or obtuse, you want to look in this column. And once you've decided if the angle is less than or greater than 90, then you want to look at the adjacent and the opposite sides. So we're going to talk about how you know which is adjacent and which is opposite in just a minute. But when you've looked at the adjacent and the opposite sides, you want to kind of compare them. And if the adjacent is a smaller number or is a shorter side than the opposite side, then you're looking at this row based on whether the angle is acute or obtuse. I am essentially not, just FYI, I am not going to give you adjacent equals opposite side. So this one in the middle, I should be doing this in black. I'm including it just for the sake of being complete, but you don't need to study this one because it is not something that I'm going to give you, so you can just cross that right out. And then the last situation is that if your, I'm running out of colors, if your adjacent side is greater than the opposite side, then you want to look at this part of the chart. And here's the thing that is most difficult to remember, and it's this one. If the angle that you're given, whatever, let's say angle that you're given is less than 90 degrees, so if you're given an acute angle and the adjacent side is greater than your opposite side, that's this situation right here, this is where you have to compute the height. And one of the things that I've noticed the past couple of days is that not everybody's sure which side to compute the height to. So just make a note to yourself that you want to compute the height to the side you don't already know. So to the side that is unknown. And we're going to run through a few examples in a minute. Remember that if we are looking at adjacent greater than opposite, and the triangle or the angle that I give you has an obtuse angle, then there's no solution there. So just remember the ones that are no solution. And also I think that it would help you to remember that anytime the adjacent is less than the opposite with the SSA case, you have one triangle, just one. And all of this is in your notes for lesson 5.3. There are also a whole lot more examples than we finished in class in that same notes packet. So if you notice in that notes packet, we didn't do, I think it was a whole entire page of examples, and I put the answer key, I think it's like numbers 7 through 10. I put the answer key to those problems on Google Classroom, so you can look for that there. And there's one of those 4 problems that's an example of two triangles that you can look at for practice, or ask me for some examples, and I can send you some examples of two triangles that you can practice. So anyway, this set of problems here, and just FYI, I don't have this printed out, and I'm not going to print it out for you, but really you don't need this from a photocopy machine, all you do is grab some scratch paper and work out some of these problems on your own. I really don't think that you need to print it. But anyway, these sample problems, your first set of directions are basically just to decide how many triangles there are. All of these 6 problems are side-side angle or SSA. I've chosen problems that fit that category on purpose so that then you're forced to use the table up above and choose which case. As I talk through them, though, what I would like for you to do is have your 5.3 notes next to you if you can, so that you can have that table. So I don't have to keep zooming out and zooming in to the table, but that you've got it in front of you. So let's start with number 1. And remember that the first thing that you want to ask yourself is whether the angle is less than or greater than 90. And so the given angle here, angle D, is less than 90 degrees. And then the next thing that I had said we would talk about is how to know which is the adjacent and which is the opposite sides. And you want to look at the letters. Remember that angle D will always be opposite side D. And so what I do is I just look for the same letter, the side that has the same letter as the angle, and that's going to be my opposite. And whatever's not the opposite is automatically the adjacent. Because it's a triangle and there's only 3 sides, once you've chosen the opposite, the other 2 sides are both adjacent to the angle you're given. So you know that side E in this case is opposite or is adjacent to angle D because they have different letters. And then you want to ask yourself, is the adjacent less than or greater than the opposite? And in this case, your adjacent, which is 13, is less than your opposite. So adjacent is less than opposite. And then you want to go and look at your chart. And for an acute angle, well, actually, it doesn't matter. Anytime you have adjacent less than opposite is automatically going to be 1 triangle. So 1 triangle, and that's what you're asked to do to start this packet. So 1 triangle. That's it. And we're not going to come back to number 1. Then in number 2, the first thing you want to look at is the angle. Angle M that you're given is greater than 90 degrees. The side with the M is the opposite, meaning opposite angle M, and therefore the side that has a different letter is the adjacent to angle M. And so in this case here, your adjacent is again less than your opposite. And anytime your adjacent is less than the opposite, then you have 1 triangle no matter what the angle is. Okay, now number 3, again I have an angle that's less than 90, so angle Y is less than 90, or it is acute. And then side Y is opposite angle Y, therefore side Z must be adjacent to angle Y because it's got a different letter. And in this case, your adjacent is greater than your opposite. And this is the combination, acute angle, adjacent greater than opposite. That's the situation where you have to compute the height of the triangle. And so what I'm going to do is, and I'll remind you that I don't require that you set your triangle up the same way that I set my triangle up, but it is the only way that you can compute the height to tell you if it's 0, 1, or 2 triangles is if you make the height go to the side that you don't know. Meaning, I know side Y, I know side Z, so I'm looking for the height of the triangle that goes to side X. But the way I've been working out these triangles is that I take the angle that I know, which in this case is angle Y, and I put it in the bottom left corner. So I know that angle Y is 21 degrees, and I put side Y over there, because it's got to be opposite angle Y. And then I take the other side that I know, in this case the adjacent side is side Z, and I put that number there. Well, if that's side Z, then this has to be angle Z down here. If it is a triangle, then it's going to be angle Z, and then the only thing left is angle X up at the top. So remember that I'm going to find the height to the angle, or to the side that I don't know, and in this case that's little x. So when I say I want to find the height to the side that I don't know, I am going to drop the height perpendicular to that side. So it's perpendicular to the side that I don't know. And so that's the height that I'm going to find. And remember that if the rationale, you don't have to memorize the rationale, you just need to know how to compute it. But the rationale here is that if you look just at the height and the stuff toward the angle you know, so from the height toward the angle you know, what I've just shaded in blue is a right triangle. And if I want to compute the height of that is going to be sine of the angle that I have there, which is 21 degrees, equals h over 47. Don't be confused by h. H here is the height, not the hypotenuse. So if you look just at that blue triangle and you solve for sine of 21 equals h over 47, every single time you're going to be taking the adjacent number that's given, this one, multiplied by the sine of the angle that you're given, so multiplied by the sine of this. So you don't even really need to write out the proportion in this case. You just have to know that in your calculator you're multiplying 47 times sine of 21. And when you do that in your calculator, which apparently I didn't do ahead of time, my apologies while I type, I get that h is equal to, in this case, 16.84. And so let me write that over here. H equals 16.84. Now I want you to imagine this triangle here. And I want you to kind of imagine that there's a hinge up at the top and that this side could swing back and forth. And if this side is 16 long and it's swinging back and forth like a pendulum, it's not going to meet the bottom. It's not going to meet the bottom down here because it's 16 and the height is greater than 16. So there's this little bit of space right here where that's not going to meet, that the triangle is too tall, for the opposite side to meet the bottom. So let me zoom out a second and let you take a look at that. And why don't you go ahead and pause the video and make sure, first of all, that you understand why on this problem and not on number 1 or number 2 that I computed the height. And then make sure you understand why my answer for this problem is going to be no triangle can be drawn, or no solution. All right, so let's look at number 4. And remember that the first thing that you want to do is make a note that the angle that you're given is less than 90 degrees. You want to decide which side is the opposite. B is the opposite because it's got the same letter as angle B. And A is adjacent because it's got the different letter. And in this case, your adjacent is greater than your opposite. And in this case, remember, this is the same as problem number 3, that when you have your acute angle less than 90 and the adjacent is greater than the opposite, that's when you have to compute the height. So I'm going to go through the same process as the previous problem to compute the height of this triangle. And again, you don't have to draw your triangle facing the same way that mine is facing, or put the sides or the angle in the same orientation that I have mine drawn, but you have to draw the height to the side you don't know. You have to make it perpendicular to the unknown side. So I am going to put my angle that is 37 degrees down on the bottom here. That's angle B, and this is 37 degrees. And then side B, I don't know if it touches over there or not, but that's 11, and side A is 14. If that's side A, then this has to be angle A, and then this is, what did I say, angle C? It's triangle ABC. Yep, ABC. And I need to find the height to the side I don't know. I don't know side C, and so I have to compute the height here. And remember that H is always going to be the side that's next to the, or adjacent to the angle I know, times the sine of the angle I know. And so here I'm going to do 14 times sine of 37 degrees. And again, I didn't do that ahead of time, so let me work that out. 14 times sine of 37 is 8.43. And so this height here is 8.43. So now we have a situation where the opposite side, so this meaning the opposite of the angle I know, 11, is bigger than the height of the triangle. Or if you think about it like this, if this were a pendulum and it was swinging, and in fact I made it too short, if it were a pendulum and it was swinging, this would swing down like this, right? And so this side that's 11 would not only touch the triangle over here, but it would also touch the triangle over here. And so that side that's 11 would go in two different directions and create two triangles. So if the opposite side is bigger than the height, that's when you have two triangles. And we're going to come back in a minute and solve this one. But for now, just make a note to yourself that this makes two triangles. And then I just want you to pause for a second, put the video on pause, and think about why we computed the height in the first place, and why the answer says two triangles, and that we're going to have to solve both triangles. Now in number 5, again, we're going to start by looking at the angle that you know. So angle H here is greater than 90. It's obtuse. And if angle H is given, then side H is opposite and side F is adjacent. And I hope you can see that the adjacent side here is less than the opposite. And I really meant this problem to be the other way around, with the opposite is less than the adjacent, but I guess I didn't. So anyway, when you've got adjacent less than opposite, no matter what the situation is with the rest of the problem, you'll always have one triangle. So one triangle there. The reason that I didn't want to use those numbers, I am surprised that I did, is because it's like number 2. So the next thing that I would ask you is to look at number 5 and look at number 2 and make sure that you see what I'm talking about, that those two problems are similar. They both have an obtuse angle and they both have adjacent less than opposite, so they're both one triangle. And in fact, numbers 1 and 2 and 5 all match with that top row of your chart where the adjacent is less than opposite, so there's one triangle. And you solve it just like you do any other law of sines problem. Now, for this last one here, angle R is less than 90 degrees. Side R is opposite and side Q is adjacent. And in this case, adjacent is greater than opposite. And again, remember that when you're talking about an acute angle and the adjacent is greater than the opposite, this is where you have to compute the height. If both of those things have to be true in order for you to need to compute the height. So for this one, I'm going to put angle R down in this bottom corner, and we said angle R is 54, and this is side R over here, 19, this is side Q over here, which is 23. That makes this angle Q, what was my other letter? Ooh. What? Sorry, you can't see the stuff that I'm seeing. I'm so glad. My other letter was PQR, so this angle at the top is P. And I said I have to compute the height. Remember that you compute the height to the side you don't know. I don't know side P, and so I'm going to draw my height perpendicular to side P. And then I'm going to compute H by multiplying 23 times the sine of 54 degrees. So 23 times the sine of 54 degrees. And you know I didn't do these ahead of time. My apologies. So 23 times sine of 54 is equal to 18.61. So I get that the height is 18.61. H is 18.61. And remember that if your opposite side is longer than the height of the triangle, or the altitude of the triangle, then that means that there's going to be two triangles that you can draw and solve here. So this answer is two triangles. And in a minute, I'm going to solve those two problems. So again, I'm going to ask you to just take a minute, pause the video, and then when we come back in a minute, I am going to take number 4 and number 6, and I'm going to solve them below. So here is example 4, and remember that we decided it's two triangles and we're going to solve it for both triangles. And the first thing that I want to do is actually redraw what I had drawn on the other side, and I'll be a little bit more careful this time to draw it a little bit more accurately. So if this is angle B is 37 degrees. And this would be angle A, side B is 11, side A is 14, and this would be angle C, and this would be side little c. And remember that you had drawn a height from angle C to side C, and that was the one that we said, I'm going to make this really small, that we had said the height is 8.43. You don't need that number anymore, but I just kind of want you to get a sense of what you had already drawn on the front. And then the idea here is that the side that is 11, the side that is 11 over here could also be drawn at a different angle. You can change angle C, for so to speak, to draw that side going this way. So this line would also be 11, have a measurement of 11. And now we're looking at two different triangles that have a side that's 14, a side that's 11, and an angle that's 37. And those two triangles are this smaller obtuse triangle here, or now remember that this is going to be the big, huge triangle, this triangle on the outside. And for a little bit, we're going to ignore the triangle that's white space right now. So let's look specifically at solving the big triangle first. So you know I like to redraw it, so I'm going to redraw that and call it angle 1. You have to solve, or triangle 1, you have to solve the big triangle first because you need one of those measurements to solve the smaller triangle. So this angle is 37 degrees, this side is 11, this side is 14, and we still need to solve for angle A, angle C, and side C. So I'm going to use the law of sines, and at this point, this problem shouldn't feel any different from any of the other problems that we have worked on as far as solving for the different parts of the bigger triangle. So I'm going to start by looking at, I know angle B and I know side B. So that's going to be the first part of my, my proportion is going to be 11 over sine of 37. And then I know side A, and so I'm going to solve for angle A. That'll be the easiest thing to start with. So I'll solve for angle A, and that's going to be 14 over the sine of angle A. Remember that in your calculator, you want to, I'm sorry, I put that off the screen. So in your calculator, you're going to type, don't write this part, please. What I want you to write, what we showed you with the proportion here. What I'm about to write in orange to the left, I don't want you to write on your paper. I just want you to type it in your calculator. But remember that you're multiplying the two numbers that you know that are diagonal. So I know the 14, I know the sine of 37, and so I'm going to, in the numerator of a fraction, I'm going to do 14 times sine of 37. Please use the fraction function in your calculator. Don't try to do that as a division problem. The students that I'm seeing having trouble with calculator steps are the ones who aren't using the fraction. And then I'm going to divide by the thing that's diagonal from the angle that I'm looking for. So I'm going to divide by 11. And, excuse me, when I do that, I get 0.7659 or something. But you don't need to write that down, 0.7659. You don't need to write that down. You get all those decimals. But that's the sine of A. That's not A. So then what you want to do is you want to do second sine and second negative to get the answer. So second sine gives you your sine inverse and an open parentheses. And then if you do second negative, not minus, but negative, the button down at the very bottom of the calculator next to the decimal, it's going to tell you ANS, which just means that it's going to go back up and pull your most recent answer. And all of that should tell you that angle A equals 49 point, I wrote that wrong and you can't see it, 49.991, and so that just stays 49.99. And at this point then, when you know two angles, and I know the 37 and I know the 49.99 degrees, at this point, when you know two angles, always use subtraction from 180 to solve for the third angle. And you have the 49.991, 26, etc., 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 etc. in your calculator already. So do 180 minus 37 minus, and then do second negative to get your answer. Again, ANS. And that should give you 93.01 and so on. And so that's going to be the best way to find the angle C. 93.01 degrees. And you still need to solve for side C on the big triangle, but let me just give you a minute to look at all those numbers, make sure you understand everything. And then to find side C, I didn't leave myself enough space underneath, but to find side C, I'm going to start with 11 over sine of 37 again. So 11 over sine of 37 degrees. And then I want side C over the sine of, and this is the number that I just computed, 93.01. And because it came with a bunch of decimals in your calculator, when you type this in, you're going to type the fraction numerator 11 times sine of, and then just pull that answer in. So in your calculator, it's going to look like fraction 11 times sine of ANS, which pulls that answer all over, you're looking for C, so it's, sorry, lost track of what I was doing, sine of 37. So that's what you're going to type in your calculator. And then when you've done that, you should get that side little c is equal to 18.25. So now you've solved the big triangle, and I'll pause there for a second and let you finish writing, and then we're going to solve for the smaller obtuse triangle. So the second triangle is the one that I highlighted here in yellow. But in order to understand that triangle, remember that this white space here is an isosceles triangle. It's isosceles because you've got two sides that are the same. And if two sides are the same, then you know two angles are the same. Well, we've already solved for angle A, and so we're going to use that measurement to help us find the smaller of the two triangles. So let's come down here, and I will draw triangle 2, and it's obtuse like this, and it's smaller. And remember that we're not going to call it, we're not going to call the angles A and C, we're going to use primes. So this is angle B, and angle B has the same measurement in both triangles, so that's 37. Side B is 11 in both, and side A is 14 in both. But here, angle A is going to be different than the other angle A, so we're going to call it angle A prime. And up here at the top, this is a different angle than the one that we computed for angle C, and so we're going to call that angle C prime. You always want to start by computing angle A prime. And so a minute ago, I said over here that we're looking at these two angles because we computed already that angle A in the big triangle is 49.99 degrees. Therefore, this angle has to be 49.99 degrees. Well, if that angle is 49.99 degrees, you should see that that's this angle, that's this exterior angle here, that's also 49.99 degrees. So I want you to make sure before you go on that you understand why this angle is the same as this one up here, the exterior angle. And so to start solving this smaller obtuse triangle, to get the interior angle, that's where we're going to subtract 180 minus 49.99. And when you do that, you should find that angle A prime. And this first angle, this first interior angle is always going to be the obtuse angle. So if you get a number that's not bigger than 90, something's wrong. And so in this case, you should get 130.01 degrees. Now you know two angles. You know angle B, which was given to you, and you know angle A prime. And so in order to solve for angle C, you just subtract 180 minus 37 minus your previous answer, which is the 130. And so you should get that angle C prime is equal to 12.99 degrees. Last but not least, remember that you're going to have 3 measures for each triangle. And so I still need to solve here for side little c prime. And so I'm going to go back to the 11 over sine of 37 that I've been using, because those two numbers are both in this triangle, 11, and the opposite angle is 37 degrees. And so 11 over sine of 37 degrees equals little c prime over sine of, and then the 12.99 should be the last number in your calculator, so you can just use sine of answer. So your fraction is going to be 11, in the numerator, 11 times sine of 12.99, or sine of answer. Don't type the 12.99. And then the denominator is sine of 37. And you should find that side c prime is equal to 4.11. Now you have 3 measurements for each of the 2 triangles. You pull that out just a little bit, and I will stop talking for a moment while you ponder all of that. Every time I make a video at school, somebody knocks on my door or just lets themselves in, because teachers have keys, you know, and just talks to me and then says, "Oh, were you making a video?" I'm not going to go back and delete the knock. My apologies. It's ridiculous. I think you need to go get some chocolate ice cream. Chocolate ice cream. I was told that that was funny. I don't know. Okay, let's do number 6. If you don't want to do number 6 yet, pause it. Otherwise, I'm going on to number 6. I'm going to give less calculator explanation with number 6. But for me, because I'm visual, I need to draw just as much. So as much as you've seen drawn out up on top as far as the triangles and the labels go, I need to do that for myself. So let's take a look at number 6. And I'm going to just draw the whole thing from scratch again. So we have triangle PQR, and we've got angle R. This is not entirely an accurate scale, but we've got angle R down in this bottom corner, and it's too small to actually be 54 degrees, but just play with me and pretend like it's 54 degrees. This is 19. This is 23. If that side is 23, then this side is Q, or this angle is Q, and then the other one, the P, has to be up on top. We had computed the height, so remember that the height always goes to, or it's perpendicular to the side that you don't know. So this is side little p, and we said that the height here was 18.61. And so your side R that's 19 could either be over there on the right of the height or the altitude, or it could be over here, that side, it could be drawn there. And if that's 19, then you also have a triangle. You have the big triangle, the big, huge, ginormous triangle that has side angle 19, 23, and 54 degrees. That's the big outside triangle. And we're solving for first. Excuse me. And then the second triangle, and I think the key to understanding why this works is because the obtuse triangle here on the inside, right here, this triangle also has side angle 19, 23, and 54 degrees. And again, that's why in geometry class 2 years ago, your geometry teacher said you can't use side angle to prove two triangles congruent, because you could have 19, 23, 54, and it's and you've got the big triangle, and the other triangle might be 19, 23, and 54 and be the smaller obtuse triangle, and you don't know that, so you can't prove that they're congruent unless you know more measurements of the triangle or a different arrangement of them. So anyway, I am going to solve the big triangle first every time, because we're going to need angle Q, the answer to angle Q, in order to solve for the smaller triangle. So I'm going to redraw all of that. I will be quick about it. Here is angle R, which is 54 degrees. This is P, this is Q, this one is 19. I don't like my 19. This is 19, and this is 23. And I need to solve for angle Q, angle P, and side P. So I'm going to label that P. Remember that you want to look for where you know a side and an opposite angle here, and that's going to be the first part of your proportion. So 19 over sine of 54. And I also know the side that's 23, and that's opposite angle Q, and so I'm going to say 23 over sine of Q when I'm solving for angle Q. Now remember that when you type that into your calculator, you're going to get the sine of Q, and you need that to be Q itself. And so you want to take, and I'm typing it in real quick now, so that when you do 23 times sine of 54 over 19, you're going to get something like 0.97933. That's the sine. And then what you want to do is do second sine to get the inverse and second negative to get the answer. And you should find that angle Q is equal to 78.33 degrees. And now you know two angles. You know this angle that's 54 that you were originally given, and you know angle Q. So just do 180 minus 54 minus the answer with all the decimals, and you'll find that angle P is equal to 47.67 degrees. Don't forget your degree symbol. And so those are the two angles. Now I need to solve for side P. So I'm going to use 19 over sine of 54 again. And this time I want side P over the sine of angle P, and angle P is 47.67, which should be the last thing in your calculator, so that you can pull that into your equation without retyping it. Remember also that if you press second enter, instead of needing to retype an entire thing, if it's going to be very similar, like this, you have 19, you have 23 times sine of 54 divided by 19 farther up on the screen. You can either do second enter multiple times, or you can up arrow to grab that, and that way you don't have to type in the whole thing again. When you do all of that, you're not getting the sine this time, so you don't have to use inverse sine. You're just going to get the length of the side. So here, side P is equal to 17.38. And if you need to, pause the video for a minute take a look at how I solved the first triangle, and then we'll solve the second triangle together in just a moment. Okay, so remember that the second triangle that I'm solving is the triangle that I originally highlighted yellow here. And when I keep talking about the obtuse triangle, notice that this angle here is always going to be obtuse. Always, 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 always. That triangle is going to be obtuse, or that angle is going to be obtuse. And so when you're looking at your isosceles part of the triangle, these two angles are going to be the same, and we already decided that angle Q here is 78.33, and so this angle right here is also going to be 78.33, and that's the angle that's exterior to the yellow highlighted angle. So let's redraw the triangle, the yellow highlighted triangle. I'm sorry, I said that wrong. Let's redraw that yellow obtuse triangle here. So you've got angle R here that's 54 degrees. Side R is 19, side Q is 23. We're going to call this Q prime. We're going to call this P prime. And then we're going to call the side little p prime. And when we were talking just a minute ago about the exterior angle, we're talking about this angle here that's exterior to angle Q prime. That's your 78.33. And so to solve for the interior angle at Q prime, you're going to do 180 minus 78.33. And that's going to give you the obtuse angle Q prime. So angle Q prime is equal to 101.67 degrees. And then once you've got two angles of a triangle, so you've got the 54 degrees and you've got the angle Q, which is 101 degrees, then you just subtract everything from 180. And so to find angle P prime, 180 minus 54 minus the answer, the previous answer should be the 101.67, and here you should get 24.33 degrees. Now, oftentimes this angle, not always, but oftentimes this angle will be very much bigger than that, and this angle will be very much smaller than that. So you might get an angle here that only has one digit before the decimal point, and that's fine. What's going to be wrong is if your first angle here isn't obtuse. This angle has to be an obtuse angle, has to be, or you're not doing the problem correctly. So the last thing I need to do is solve for little p prime. I now know angle P prime, and I'm going to go back and use my 54 degrees. Our angle R is 54 degrees and side R is 19 degrees. And so I have 19 over sine of 54 equals, and then I'm looking for side P prime, little p prime, and then I'm going to do that over sine of 24.33 degrees. And remember that you don't want to type this number into your calculator. This should be your previous answer, and so just use 19 times sine of answer for your numerator, sine of 54 for your denominator. When you type that in, you should get little p prime is equal to 9.68. That's also sometimes a very small number. You might get a very small number for the length of that side of the triangle. Anyway, there's number 6. I'll shut up for a couple of moments while you finish looking at that, run some stuff through your calculator. And again, let me know if you want more practice problems with two triangles, because I'm happy to send those along to you.